So in this video and the next one or two videos, I'll be explaining how to do problem numbers 5, 10, 11, and 12. And you heard it from me first. 5, 10, 11, and 12 are the only types of problems that you will see on your test on Wednesday. So hopefully you're watching this video and you don't have to study everything. Only the piecewise functions and the graphing absolute value functions. Those are the only two concepts that will be covered on the test on Wednesday. Alright, so here we go. Problem number 5. We have to come up with a definition for the piecewise function that we see that's graphed here in problem 5. So we know first of all that there are three pieces. We can see 1, 2, 3 pieces. The first piece, and we always define these functions from left to right. So the first piece, we will just assume that it's going on forever, is defined when x is less than negative 1. X is less than negative 1. So we can see negative 1 right here, and the first piece ends right there at negative 1. While the second piece starts at negative 1, and where x is not equal to negative 1, and then the second piece is defined until x is equal to 2 and including 2. So we're going to include 2 because there's a dot there. We have a less than symbol, negative 1 less than x, which is less than or equal to 2. Okay, and then the third piece is defined, we're going to assume it keeps going, is defined for all the x values that are greater than 2. Alright, so we've got those pieces in place. So the most difficult piece of the three pieces here to define would be this part of the piecewise function here. So this line, alright, so this line goes through the point, let's see, negative 2, negative 8, sorry, negative 2, 8. And then it also goes through that point right there, and we see that point has coordinates negative 3, 11. So hopefully we can see that, and maybe I can zoom in here a little bit. Alright, that's a little bit better. So if we want to come up with the equation of a line that goes through 2 points, we would first find the slope of the line that goes through. We could use the slope formula, 11 minus 8 over negative 3 minus negative 2, or we could just count down 1, 2, 3 and over 1. So the slope of the line is down 3 and over 1, which is just down 3, which means it's negative 3. We could also replace, so if we look at the slope, point slope form of a linear equation, we could put the x1, y1. We could count the y1 to be 8, let's say. Slope is negative 3, and the x1 would be negative 2. So x minus negative 2 would be an x plus 2. So we could do that. Y minus 8 equals negative 3x. Let's put that plus 2. Let's cruise up over here. Let's go ahead and distribute the negative 3 to both terms here. Negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. And then if we add 8 to both sides, we could get y equals negative 3x minus 6 plus 8, or plus 2. Alright, so that negative 3x plus 2 is what f of x is equal to when x is less than negative 1. So we would put that piece right there. Now if you wanted to eyeball that, instead of going through all that work to find the y-intercept, you could keep following this line down, and let's just say it did go through the y-axis. Where would it hit the y-axis? Well, since the slope is negative 3, you go down 3 and over 1, down 3 and over 1, down 3 and over 1. It would hit right there at 2. So if the line did extend, it would hit 2. It would have a y-intercept of 2. So that would be another way that you could actually figure out what that y-intercept would be. Just count. Alright, so let's look at the next piece. We could see that the next piece has a y-intercept of 3. and it has a slope of up 2. So let's see, we go up 1, 2, and over 1, up 2 and over 1. So the slope of this line is 2 over 1. So we know then that the equation of the line, y equals mx plus b, we just talked about that the slope, the slope is 2 and the y-intercept is 3. So the middle piece is defined to be y equals 2x plus 3. So f of x equals 2x plus 3 when the x is between -1 and 2, not including -1, but including 2. All right, and then finally, the third piece, we already determined that it was defined when x is greater than 2, but it has a y coordinate. All the y coordinates are 3, so it has a y value of 3 that's constant, and so we would just place a 3 right there. In fact, so that is the f of x defined. And if we want to find f of 5, we would figure out, well, which piece do we plug 5 into? And we could even look at the graph. F of 5 is 3. That would make sense because when x is greater than 2, the input x is greater than 2, which 5 is, then the output would be 3. Now, what would f of -1 be equal to? Well, f of -1, we have to find a place for that -1. Can't plug it into the first piece because it says that the x's have to be less than -1. Can't plug it into the second piece because it says the x's have to be greater than -1 but less than or equal to 2. And so if we look at the graph, that would make sense that there's open circles there, so f of -1 actually does not exist. And then finally, what is f of 2? Well, you could look at the graph. We could see that the y coordinate is, 7. Or we could plug 2 into the second piece because 2 is less than or equal to 2. So we would multiply 2 by 2 and add 3 and we get 7. So there you have it. Just reminding you that the only concepts being tested on Wednesday are piecewise functions and graphing the absolute functions, absolute value functions.